Hello everyone, my name is Skaty Ganji and currently I am a senior field engineer at Apple. I have joined Apple 2 years ago, and as part of this role I am aiming to bring Kubernetes and cloud-native expertise to different teams and products within Apple. As well, I am one of the TOC or Technical Oversight Committee member for CNCF. As part of this role, I am joining 10 other champions within the industry, and we try to provision a technical vision for the CNCF landscape. I have many other roles in the community, one of them being the creator of the Cloud Native Fundamentals course, which you'll be able to find on Udacity. Also, I am one of the co-lead for the KCNA exam, or Kubernetes and Cloud Native Associate Certification. In addition to that, I'm an industry-awarded professional, and this year I have been awarded with the Next Generation Leader by the Women in IT Awards, and also I have won the Tech Women 100 within the UK. Today, however, I would like to talk about sustainability chronicles, and more specifically how we can innovate for green technology by using Kepler and Keda. And to begin with, I would like to introduce the notion of cloud sustainability, and more importantly, why the tech sector should address their carbon emissions. Here I'm going to talk about a strategy as well on how we can introduce sustainability in your day-to-day decision-making process. Next, I would like to apply sustainability to the cloud-native context. So pretty much, how can you address emissions within your Kubernetes cluster? First, I'm going to talk about Kepler, which will allow us to create this inventory of our emissions and visualize our carbon footprint. And next, I'm going to talk about Keda carbon-aware operator that will allow us to scale our applications based on carbon intensity. Now, I would like to start by giving an introduction to the cloud-native landscape. Currently, it is composed of 175 projects and growing, and all of them extend Kubernetes functionalities. This landscape allows the flexibility to create a platform that enables our product with minimal compromises. This is the landscape that we, the TOC, are working with and liaise with every single project to ensure that they reach the maximum potential in maturity. Now, currently, all of these projects are dispersed for 3 different levels of maturity. We have sandbox, incubation, and graduation. Now, sandbox projects are greenfield ideas that provide a solution for a niche problem space. Next, we move towards incubation, and these are the projects that already have usages in production, but at the same time, we see diversifications in contributions from different organizations. And lastly, we have graduated projects. And these are the projects we refer to as the projects who cross the chasm. So we moved from the early majority to early adopter stage. These projects provide an industry standards for the solution in that problem space. Now, currently within the CNCF, we have 109 projects within Sandbox, 36 in incubation, and 24 in graduation. I would also like to draw your attention towards the faint gray line at the top of the graph. Now, this gray line represents the archive projects, and I don't think we talk sufficiently about archivals. Sometimes we have projects that do not reach the momentum in terms of adoption and contribution, and it's only natural for the maintainers to take the lessons learned and move towards a new initiative within the landscape, or perhaps create a new project that they would open source. Now, considering the ongoing success for Kubernetes and the growing cloud-native landscape, you might ask yourself why sustainability matters, and more importantly, how it can be applied to the cloud-native context. The short answer to this question is that currently we have multiple incentives to intertwine the economic growth with cloud and digital sustainability. And this is because of the 2 factors that happened. The first one is COP21, which took place in Paris in 2015. And this led to an international agreement to keep the global warming between 1.5 and 2 degrees Celsius. The second factor is the UN SDGs, or Sustainable Development Goals. SDG 13 focuses on climate action and the fact that as a humanity, we actually need to think about sustainability in a proactive manner. Now, this resulted with regulations at the national levels that in turn resulted with different organizations reporting their greenhouse emissions. And we can see this in numbers as well. Now, currently, the tech sector is responsible for 1.4% of total greenhouse emissions. Now, if we'd move to use renewable energy for running our infrastructure and products, these emissions would drop by 80%. However, if we don't take any action, we would be responsible for 10% of global emissions within a decade. Now, as you can see, we are at a crucial point within the industry. We need to drive remediation strategies for our sustainability, build internal expertise, and ensure that we think about sustainability on a daily basis. Now, as part of these missions, we already have the big cloud providers setting net zero targets for themselves. Now, when we're looking into the renewable energy, we have AWS and Azure aiming to do so by 2025. GCP already runs on renewable energy since 2022. Now, when we're looking into offsetting the carbon footprint, we currently have the big cloud providers setting 2030 as their goal. AWS will aim to achieve that by 2040. In addition to that, we have Azure, which is setting further ambitious goals for themselves, and they would like to reduce deforestation, be water positive, and achieve zero waste certification. However, again, we should actually not only rely on the cloud providers to address sustainability, we need to integrate that as part of every single org. And this led to the creation of a new school of thought, which is known as GreenOps, which derived from the FinOps Foundation. Now, GreenOps encapsulates all of the tooling, processes, culture, and behavioral changes required and are related to digital and cloud sustainability. Now, why it actually derived from the FinOps Foundation? This is because we can see a direct correlation between running your infrastructure efficiently and having a positive sustainability impact. So if you're running FinOps principles, or you're trying to go for them, you would perhaps run on spot instances, or you would like to move from a SaaS solution to serverless, so pretty much running an instance of your application only when required. Perhaps you're changing the programming language for your application to use something that is more optimal for your containers. Now, all of these FinOps principles will result into a positive sustainability impact, because the less compute you use, the less emissions you're going to have. And we can link actually sustainability to direct profit for your organization. And in addition to that, the Environmental Sustainability Working Group from the FinOps Foundation came up with a strategy on how to integrate sustainability in your day-to-day operations. The first phase is going to be awareness. Here's where you'd like to introduce sustainability to all of the stakeholders internally. You want to talk about your carbon footprint and energy consumption. Next, we're going to have the discovery value stage. Here's where we do the POCs. Now, if you're using a cloud provider, you'll be able to use the sustainability calculators or carbon footprint calculators. So you already will be able to create that baseline. As well, at this stage, you might look into tooling such as Kepler and Keda that I'm going to talk on in the next section. The next stage we're going to have is the roadmap. And here's where we'd like to implement some of these operations and implement them in our day-to-day work. And here as well, what we want to do is to identify those anomalies and to address them. So we want a qualitative assessment of our emissions. And finally, we have repetition and execution. Now, as part of this phase, it is very important for us to have sustainability goals set up internally. And more importantly, we want to iterate for all of these processes and revise all of our tooling and automations to ensure that we reach the sustainability goals in an ambitious manner. Now, measuring the carbon emissions and our greenhouse emissions is just the first step towards mitigation and management. We need to build this muscle of carbon accounting and to create this inventory of emissions for our entire work, different teams, products, and services. Now, how can you do so in a cloud-native context? If we're running Kubernetes, how can we measure our carbon footprint? Well, for that, we have a new tool which emerged within our ecosystem, which is called Kepler. Kepler is a Kubernetes efficient power level exporter that uses eBPF to trace power-related stats for your containers and nodes and export those as Prometheus metrics. Now, Kepler was created by Red Hat and IBM in 2022, and it was admitted within the CNCF as a sandbox project in May 2023. Now, I'm going to put my TOC hat on here. You can see that Kepler is a sandbox project. As such, we need more diversifications and maintainership and contributions. If you have any usage for Kepler, if you have any POCs already running internally, I definitely encourage you to reach out to the maintainers and become an active contributor. Now, let's look into how Kepler works. Currently, it is going to be deployed as a daemon set, which means we're going to have a replica of the Kepler exporter on every single node. And this will allow us to collect two levels of metrics: container level metrics and node level metrics. And pretty much we're going to look into power consumption and resource utilization. This is going to be done for eBPF by tracing the CPU performance counters and Linux kernel trace points. All of these are going to be exported as Prometheus metrics, and this is where we aggregate all of our data, and we'll be able to visualize them in a tool such as Grafana. Now, how exactly does Kepler calculate the carbon footprint? This is going to be done for free emission gases. We're going to look at coal, petroleum, and natural gas. The first thing we're going to need is our input value. This is going to be the amount of energy that our application consumes. And this is going to be measured in kilowatts hour. Next, we multiply this amount of energy we consume by an emission factor. And this is a constant. Now, these particular coefficients I have taken from the US Energy Information Administration. Now, this emission factor represents the amount of carbon dioxide that is emitted per unit of kilowatt hour consumed. And the end result is going to be the amount of CO2 we have per emission gas. And how it's actually going to look like? If we use the Grafana dashboard for Kepler, the first thing we're going to be faced with are free gauges for every single emission gas. So here we have coal, petroleum, and natural gas. If we look at natural gas, we're doing pretty well in terms of emissions. But if you look at coal and petroleum, this is where perhaps you would like to assess, address, and iterate. If you look at the top of the screenshot, you'll be able to see these coefficients or emission factors that are hard-coded. Now, very important here, if you're running in AWS or GCP in a particular region, you'll be able to override these coefficients with the data provisioned by these cloud providers, allowing you to have a more granular and realistic data about your emissions. In addition to that, you'll be able to see the data aggregated per container, namespace, and per day. Again, these are very good dashboards for you to assess the spikiness in your emissions, and ideally you would like to address them over the time. Now, with Kepler, we are able to create this inventory of our emissions, and we'll be able to divide that per team, products, and services. What happens if you'd like to be more proactive in terms of how we use and schedule our workloads, having sustainability in mind? Well, for that, we're going to use Keda Carbon Aware Operator. Before I talk about the operator, I would like to give a very quick introduction to Keda, which is an event-driven autoscaler, and pretty much the name says what it does. It scales our application based on an event that is triggered outside of the cluster. Keda currently has been developed by Red Hat and Microsoft in 2019. It moved to CNCF Sandbox in 2020, and it moved to incubation a year later. And this year, we're actually very happy to welcome Keda as a fully graduated project. Again, with my TOC hat on here, Keda is a great example to showcase the maturity growth of a project. And I definitely encourage you to go through the due diligence docs to actually understand how the project reached this level of maturity. Now, how Keda works. To scale any application with Keda, you will need a scaled object CRD, or customer source definition. Now, the scaled object is going to have two levels of configurations. The first one is going to be the application we'd like to scale. This can be a deployment, a stateful set, or another CRD. The second level of configuration is going to be the actual trigger. So what event do we need to monitor and assess in order to scale our application? With Keda, we'll be able to scale our application all the way to 0 and to 1, but more importantly, it works in conjunction with HPA, or horizontal pod autoscaler. So we'll be able to increase the amount of replicas to a desired number defined by the user. It is worth to mention as well that Keda has a very rich portfolio of scalers, and currently there are more than 64 scalers that we can actively introduce and use for our scaling of applications. Now let's go back to sustainability. How can we scale our application based on carbon awareness? Well, for that, we have a carbon aware operator that aims to optimize our carbon emissions and environmental impact by scaling our workloads based on carbon intensity. Carbon intensity is pretty much the grams of CO2 or carbon dioxide equivalent emitted per unit of kilowatt hour consumed. So for example, if you're plugging your infrastructure completely into a wind farm or a solar farm, pretty much you're using renewable energy 100%, your carbon intensity is going to be 0 or close to 0 because you do not emit any carbon while consuming this energy. In a more realistic example, however, you are plugging your infrastructure to a grid that has multiple sources of energy. Some of the energy can be produced by burning the coal or fuel. Some of it can be renewable energy. So you're going to have a different level of coefficient for your carbon intensity. So how exactly we can scale our application based on carbon emissions? Well, for that we're going to use a carbon-aware Keda scaler, CRD, or customer source definition. If you look into the specs section, the first thing we're going to do is reference our scaled object, which is managed by Keda. Here is pretty much where we say that we want this particular application to be scaled up and down. Next, we're going to have the carbon intensity forecast. So with Keda Carbon Aware Operator, you are able to plug it in directly to third cloud providers and to extract this data of your emissions in real time. So some of these providers are watt time and electricity map. However, for this particular example, I have used MOG data. So my carbon forecast MOG data variable is actually going to be set to true. And lastly, towards the end section, this is where we describe the behavior of scaling our application. The main idea here is that if the carbon intensity is high, we want the lowest amount of replicas. If we have a high carbon intensity, that means we have more emissions. We don't want that, so we reduce the amount of replicas. And vice versa, when the carbon intensity is low, this is when we want to increase our amount of replicas. So for this particular example, we want to have 15 replicas if our carbon intensity is 543 or less, and we want to reduce our amount of replicas to 1 if our carbon intensity reaches 579 or higher. And after deploying this particular CRD, we'll be able to visualize the behavior of our application scaling. In this graph, the top line represents the carbon intensity, and the yellow line at the bottom represents the amount of replica. Now, currently, we start with a carbon intensity of 540 and 15 amount of replicas. Towards the middle of the graph, you'll be able to see that our carbon intensity is going higher to 580, and the amount of replica is going to 1. And this kind of behavior is going to be replicated through and through based on the data of carbon intensity we're pulling from the grid. And this brings me to the conclusion today. Thus far, we have talked about cloud sustainability and why it is important for the tech sector to introduce sustainability as part of their day-to-day decision-making. Next, we looked into how we can build this inventory of our emissions by using a tool such as Kepler. But more importantly, we can actually take action, direct action within our clusters on how we scale our applications based on carbon intensity and using Keda Carbon Aware Operator. And all of this has been possible because the cloud-native landscape is growing, and it is a point where it embraces this new tooling that allows us to innovate for green technology and being aware of our carbon emissions and environmental impact. And without saying, we are hiring. If you would be interested to work for Apple anywhere in the world, I definitely encourage you to go to jobs@apple.com, where you'll be able to find the latest openings. I'm more than happy to answer any questions in regards to the recruitment process or the experience of working at Apple. If you have any questions in regards to today's talk, I'm more than happy to answer thereafter, or you can find me on social media such as Twitter and LinkedIn. This is Skaty Ganji, and I look forward to seeing how you can shape the cloud-native ecosystem. Thank you, and enjoy the rest of the conference.